Hello everyone, welcome to the Finite Element Analysis course using ANSYS. In this session, we are going to understand about overview of examples that will be covered in this entire course. The course is designed in such a way that the examples should help the researchers and academicians and the mentors or the educators to help students to solve the engineering problems and make them ready for the industry. The topics that will be covered in this session are the different problem statements that we are going to discuss in this entire course. What is the key takeaway from each of the problems that will be solved? How to choose a methodology for solving the different problems, and how to define the strategies in problem solving. ANSYS has defined very systematically the process for solving any engineering problem using the finite element analysis technique. The problem statement 1 reads like this. On the right hand side, we can see there are two bodies. One is a pinion, another one is rack. These two bodies interact with each other and transfer the forces. And there will be a resistance between the bodies from penetration because there will be a skin that will be defined on the interacting edges, that is contact. The problem statement reads like this. Find the torque required on the pinion to apply the force of 2500 Newton on the press by rack. If an engineer is designing this particular system for the press, if at all it has to apply 2500 Newton of force, and if a motor has to be selected, what would be the torque of the motor? By solving this problem, we are going to learn how a 3D problems are simplified to 2D without compromising on the results. The geometry on the right hand side, what we see is the surface bodies. So why only surface bodies are considered if the physical problem is having a 3D nature? We are going to understand more about this and how this 3D problem are converted to 2D and results will be not compromised even it is a 3D or a 2D analysis. Defining the boundary conditions to the pinion to apply the rotation to the body. How can we define the boundary conditions for this pinion to rotate? What the different materials and how they can be assigned to the bodies will be discussed. Then we also understand about defining the contacts or the interface between the bodies as I discussed earlier. And we also understand how to determine the reaction forces for the applied torque, or we measure the reaction moment for the given force, vice versa. With that, we'll move on to the next problem. The problem statement 2. On the right hand side, we can see there are two bodies, one having a cavity and another one is having a snap, that is the top body. Nowadays, for the injection molded assemblies, snap has become a very important feature for locking purpose rather than fastening them. Because when it is fastened with the screws, there are damages because of the plastic and the metal interface and the sharp edges. It is very important to understand how the snap is going to behave. Is it going to undergo a permanent deformation? And whether we are going to get enough force against the press fit or not. Analysis of these things are very critical. So by solving this problem, we are going to learn few things, but the problem statement reads like this. Find the force required to snap the body into the cavity. The learnings are going to be use of 3D elements for the analysis, defining the boundary conditions to the snap body to define a controlled displacement, defining the constraints to the bodies, which means how the bodies have to be fixed without affecting the results, If they are made up of different material, how the material assignment can be done for them, defining the frictional contact between the bodies, and also how can we determine the reaction forces for the load that is applied against the bottom body. Then we understand determining the stresses induced in the bodies due to loads. The stresses may be across the geometries or at the root of the snap or at the key strategic locations. The next problem statement, which is a metal frame made of hollow square tubes and the L angles. They are connected at locations at the corners by welding, and wherever the interface is there also it is being welded. The problem statement read like this. Investigate the vibrational characteristic of the machine frame using the different mounting points. Here we can see there are 4 mounting holes. On the other side also there are 4 mounting holes. When only center holes on either sides are fixed and end holes on the either side are fixed, how the behavior of the body is going to change will be studied in this problem. The learnings out of this problem are going to be what is the importance of vibrational analysis, how to define the contact between all the bodies because there are so many bodies interacting with each other. Next is defining the boundary conditions to different locations to witness change in the behavior of the structure. As I discussed, the boundary conditions can be changed either to the center 2 holes on either side or end holes on the other side. Then we understand how to define the material for multiple bodies, how to define the contact between the bodies which are going to define the actual welded connection. Then we learn about how to solve the problem to extract the natural frequencies, how these natural frequencies can be visualized with the mode shapes. Moving on. In the next problem, we can see there are 2 bodies. One is bolt, another one is nut, which are held together, and a torque is applied at the bolt and the nut is fixed. The interface between the bolt and nut are tied. The problem statement reads like this. Conduct a stress analysis on the bolt due to applied torque at hex head. Learnings. Use of 3D elements for the analysis. That is, since the geometry is complex, we cannot simplify to 2D or 1D. It has to be considered 3D analysis itself. Generally, the standard parts like the fasteners will not be analyzed. This analysis we are still conducting for learning purpose. Defining the constraints to the nut and material assignment to both the bodies. Tying the bodies with the connections to replicate the bonded connection between them. Determining the moment reactions for the applied torque. And we also learn about determining the stresses induced in the bodies due to the loads. Moving on. On the right hand side, we can see that there are 2 bodies. One is a hollow tube, another one is a flange with 4 holes. In the flange, a tube is inserted, and on the tube at certain distance a force is applied, and the flange is fixed at these 4 mounting locations. The problem statement reads like this. Conduct a stress analysis on the flange due to the force applied away from the flange. The interest here is stress analysis on the flange only, means the consideration of tube may not be required. The learning here by solving the problem are how the analysis can be conducted on just a flange and still considering the transfer of load from the tube end to the flange. How the forces can be applied on the body remotely by using the specialized boundary condition loading commands in ANSYS. Defining the constraints to the body, that is fixity at the mounting locations, and how to determine the stresses induced in the flange due to load post-processing of the results. Next problem is very interesting. It is made up of multiple bodies: shaft, bolt and nut, and the clamp. Here the statement is analyze the clamp for the stresses due to bolt tightening. When the bolt is tightened, the clamp is going to force against the shaft and the stresses will be induced in the clamp. The area of interest is to study the stresses in the clamp. By solving this problem, we learn how to deal with the assemblies or multiple bodies, how to approach for mathematical modeling of the problem which has the multiple interfaces, because we have to define the connections or the contacts between bolt, clamp, nut, clamp and shaft. Then how to apply the bolt loads and how to consider effect of fastening due to the applied torque. We have a special command in ANSYS called as bolt pretension. We learn how to use that command. Why choosing the right contact influences the stress results. Then determining the stresses induced in the clamp due to the load. The next problem, on the right hand side you can see that it is a thin, hollow, long tube and the cross section of this tube is shown here on the right hand side. The problem statement read like this: evaluate the stress induced in a pipe due to pressure. Let's assume the pipe is being supplied with a constant pressure inside and we are interested whether it is going to burst, crack, or is it going to cross the yield or not. By solving that problem, we understand how to approach to solve the problem which have a uniform cross section and acted upon by the uniform loading conditions. Which means the 3D model can be straight away simplified to 2D because the geometry is uniform, cross section is uniform, the pressure applied inside it is uniform. Comparison of stress and results between the actual 3D analysis and simplified 2D approach. Then we also understand witnessing the reduction in the time in the 2D analysis against the 3D. Once we simplify from 3D to 2D, there is a drastic reduction in the node count or the element count, which is going to save the time of computation. We are going to witness by solving this problem. The next problem statement reads like this: evaluate the deflection on the clip when it is fixed at one end and loaded at other end. The component looks very simple, but we have a very good learning out of this analysis. Here we can see it's a 3D model of a paper clip that can be simplified to the line bodies and converted to 1D model. We are going to fix at one end, apply the load at another end, and understand the behavior of this. The learnings by solving this problem is how to simplify the 3D geometry to 1D geometry, what are 1D elements and their representation. As we discussed, the elements are 1D, 2D and 3D. In this case, it is going to be 1D element. How geometric nonlinearity plays an important role in the behavior of the body when it is acted upon by the load. We are coming across one new terminology over here, that is geometric nonlinearity. Then we understand how to extract the deflection of the geometry. Next problem is also very interesting. This component you might be very much aware. It is a rooftop or the overhead tank, which is made up of plastic, and the manufacturing technique for this is the rotomolding, which has a uniform thickness across wherever we measure it. The problem statement read like this: evaluate the deflection in the tank due to water pressure when it is kept in a vertical orientation and loaded with the water. Water is going to vary its pressure from top to bottom. The learnings by solving this problem is behavior of shell elements and their degrees of freedom. Shell element is one of the key element used in the finite element analysis to capture the behavior of the thin-walled uniform thick components very accurately. The importance and application of the shell elements, and how 3D geometries with a constant wall thickness can be analyzed by considering just the mid-surface. The tank will have an inside surface and the outside surface. In between there is a constant wall thickness everywhere. Such problems can be simplified by considering just the neutral surface and analyzing them by applying the right element and capturing the accurate behavior. How to define the pressure on the internal walls of the tank. How to analyze the behavior of the bodies due to the loads will be discussed in this problem. The next problem also is very interesting. We can see kind of a propeller model or a fan model. Here it is a full model and this one is just 1/3 of it. The problem statement read like this: evaluate stresses induced in the propeller due to the rotational velocity. The learnings will be how to analyze the body subjected to rotational velocity or a speed, how to define the rotational velocity for the given bodies, and how can we define the constraints for solving the problem and evaluate the stress and deformation on the bodies. The next problem statement reads like this: if you have come across such a bodies, that is pressure vessel having a constant wall thickness and a uniform cross section about an axis, those can be simplified to just a 2D geometries, and when analyzed there will be no change in the results between 3D and 2D, which we are going to witness. If at all you have come across such a problems either in your research or during your project, then you must convince people to solve the problem by the 2D approach than the 3D approach. This approach is going to give a very good time benefit and you can conduct multiple iterations in a given time. The problem statement read like this: validate the strength of the pressure vessel due to loading, that is pressure loading. The learnings are going to be how to analyze the pressure vessel, how to simplify 3D geometry by taking just a cross section without affecting the result. Witness the benefit of time when the 3D geometry is simplified to just 2D axisymmetry. So when we simplify that 3D to 2D, we call that as axisymmetric model. What are the plane elements and how they are different from solid and shell elements? Because solid and shell elements are the elements which are used to capture the behavior of the bodies in X, Y, Z directions, and shell elements we can capture the deformations and the rotations as well. But how these plane elements are different from that, we are going to understand. Evaluation of the stresses and the deflections due to the applied pressure. The next problem statement is a simple bracket which is 3D over here and which was simplified to 2D. The problem statement reads like this: evaluate the stress induced in the bracket due to load. The learnings are going to be how to analyze the geometries which are loaded in plane and have a uniform thickness across, how to extract mid-surface of the geometry for the analysis, which is the 3D geometry may not have to be considered as is. We can just consider the neutral surface, that is the mid-surface of that, and conduct the analysis by providing the thickness in the software directly. Witness the benefit of time when 3D geometry is simplified to 2D plane stress model without compromising on the results. What are plane elements and how they are different from solid and shell elements? The next problem statement reads like this: evaluate the deflection of stress in the system due to the given load. Here we can see a shock absorber which is made up of two components and a spring in between. It is difficult to create a geometries and analyze the stiffness of the spring as is in the 3D analysis. There are specialized command in ANSYS called as spring elements. How those elements can be directly used here to study the behavior of the structures. The learnings by solving this problem are what are the spring elements and how they help simplify the actual 3D spring geometries, defining the springs and their characteristics, how to plot the load versus deformation plots after the solution is complete. The next problem is there are two flanges, LHS and RHS, which are connected by some fasteners. And those fasteners are inserted into the holes over here. How the fasteners can be simplified to just beam elements and the results can be extracted on both the flanges by conducting the FEA study. The problem statement read like this: evaluate the stress and deflection in the flange assembly when it is fixed at one end and loaded at another end. The learnings by solving this problem are how to analyze the bodies which are connected by the fasteners, how to define the connections between the bodies, what are beam elements and their application, how to extract the results like stresses and deflection on the two bodies. The next problem is very interesting and which has a more demand. The problem statement reads like this: plot the deformation, stress, strain, reaction force when the tube is subjected to 3-point bending and the tube thickness is just 2 mm and the supports are made up of 10 mm thick. So bottom we can see these are the supports and the top one is the pusher which pushes the tube against the support. The center portion is a tube which is made up of constant wall thickness. One thing you must be wondering, all these geometries are surface bodies, they are not solid geometries. Yes, these surfaces are the neutral surfaces extracted from the 3D geometries to make the analysis simple and capture the behavior accurately. The learning by solving this problem will be how to conduct a 3-point bending test, application of shell elements, how to define interface between the bodies, how to define downward push force for the pusher. That pusher, we can see that it is made up of a rigid structure which will be pushing the tube against the supports. How to define the constraint to the supports, that is defining the fixity for the bottom supports. How can we capture the results on the hollow tube, because that is the area of interest. How to define the load steps and the time step, a very key thing, because the pusher first pushes the tube then retracts back. So how do we define those steps in the analysis, and how can we maintain a controlled movement of the pusher against the tube during bending test? All these things we are going to discuss while solving this problem. The next problem statement reads like this: evaluate the stress induced in the press fit assembly when it is loaded with an axial load of 100 Newton. We can see that there are two bodies. Outside body is a hollow cylinder and inside body also is a hollow cylinder. They are in interference with each other, which means there is a interference fit or press fit between the bodies. How can we solve for this interference and extract the stresses, then apply the load on the bodies so that we are going to get a reaction force or measure the reaction forces and stress in these bodies. The learnings are going to be how to analyze the behavior of the bodies when they are press fit condition, how to define interface between the bodies while analyzing the press fit, that is contacts, what are load steps and how to define them, similar to the previous problem, how to define and assign different materials to the bodies. If at all outer body is made up of steel, center body is made up of aluminium, how can we define those materials? Evaluating the stresses due to press fit. The next problem reads like this: on the right hand side we can see a chassis of an automotive. Here, understand the vibrational characteristic of the chassis and the natural frequencies associated with the structure without any loads and with loads. So one time we are going to apply the load, one time we don't apply the load. By that, how the natural frequency is going to change will be discussed in this. The learnings are how to create a FE model for a constant wall thickness geometries, what is a governing equation for the modal analysis, and how to decide on the selecting number of modes for the vibration. The next problem, this is a very common problem you might have come across, that is plate with a hole. Very simple problem but very profound learnings we are going to have in this. The problem statement reads like this. Find the stress induced in the plate with a hole of thickness 3 mm fixed at one end and loaded at other end with a load of 1000 Newton along the length. The learning by solving this problem, we have a comparative study between the same geometry but with a different mesh. One is a default mesh, another one is going to be a controlled mesh. And what is the importance of mesh refinement at critical locations, especially at the hole, and how to choose the right element size for the analysis. I'm going to make the videos for all these examples with the in detail explanation, which is going to give you enough learning so that you will be industry ready, or if you at all you are doing a research work, that is going to help in your research work. If at all you are an educator, that will help you to help your students learn better. All these geometries will be shared to you on a request. You can be in touch with me either by phone or by WhatsApp. This is the India number 9481635839, or you can reach out to me via email, that is caewworldwide, and the email ID is caewwhelp@gmail.com. You also can visit my YouTube channel, that is youtube.com. The channel name is GRSCAD. With this, I will see you in the next session. Till then, take care and bye bye.